Hey, have you ever wondered what is a curve? Like, let's see, ax square plus bx plus c, or some other equation can show up a curve, right? Have you ever wondered that can we draw a tangent to the curve? Let's see. To find the tangent, we first have to find the slope of the given curve. How do we find the slope of the given curve? Because the slope of the curve changes continuously. The slope of the curve is also an equation. To find the equation of the slope of the curve, we have to differentiate the equation of the curve. You finally understand? Okay. G of x. Assuming g of x be the differentiated equation of the f of x. So d by dx of f of x. See, got it. G of x is equal to d by dx of f of x, which means this line here indicates the slope of the given curve. As you can see here, if you observe closely, here up to the midpoint, the graph, the red line is decreasing. That's why it had a negative slope. And after the 0 point, which is after -1 on the x-axis, it started increasing. It has a positive slope, and the slope is increasing as the curve increases, as the values of x increases. See, good, right? We have to find the slope of the given tangent at a particular point. So I want a point. Let's take a point b. I let the assume the point be p. So p comma f of p. See, add a slider to p. Look at this point p. I can move this point P, and this point moves along the red curve. See, good, right? If P comma f of P, this point equation is okay. Cool. Let's take another variable and assume we want the slope of this thing at a particular point. To find the slope at the point P, we have to find the answer. Let's see, g of p be the slope. G of p will be the slope because g is the differential equation. G of p is the slope of the given tangent at a particular point. The slope of at this point, let's see, what is the slope of this line? -5.6. Here you can see the slope value is being changed, and I want a tangent. What do we do for tangents? We want a line which passes through the point p comma f of p, which passes through the point p comma f of p and has a slope of g of p. Simple, right? See, let's write the equation y minus y1, right? What is the value of y1? F of p. F of p is equals to m. What is the slope of the line? Slope, right? G of x into x minus x1. X minus, look at here. Let me change the color of the graph so that we can look at it very clearly. I'm taking orange be the tangent color. Look at here. Is the point. See, as the p point moves, look here. As the point p moves here and there, we got a tangent. Hey, super fun, right? Fun like this. The g of x is a bit looks like a disturbance, so remove it. See, look, we have a nice looking neat tangent here. Good, right? See, how about we draw a secant? We can draw a tangent, so we can draw a secant. What is a secant? It just has a slope of which is perpendicular to it. So I'm multiplying g of p into x is equals to -1. So what will be the value of x? It will be -1 by g of p. See, got it, secant. See, these two lines are perpendicular. Cool, right? Looks so beautiful. Okay, looks great. But how about we add another curve to make it even more beautiful? See, I'm taking another curve, h of x. is equals to, let's say, A already used, sx square, x square plus not g h j jx plus and hx plus n. Like add all the values. Let's look at this. I wanna change this curve to reverse. Okay, let's have this curve like this. Cool, looks beautiful. Hmm. Let's look at this. Okay, the point looks okay. Let's attach this curve just to experimental purpose. Okay, looks beautiful. And wanna have another point on the curve. Differentiate the curve, same process. So let's take another k of x is equals to d by dx of x. This line, like I wanna make it invincible so that it won't disturb us again. So let's do the same. We have to get the tangent. So I want a point. So let's assume instead of p, let's take L, comma h of L be the point. L comma h of L be the point. Okay, L comma h of L, and then let's get the equation y minus y1, which is what is y1 h of L. Okay, how about okay no h of L and let's equals to m. The slope will be k of x, like k of L will be the slope for this line multiplied by x minus L, right? See, look at this line. This lines seem to be a little irritating, so I'm just making these lines invincible for the time being. Look here, this graph. We got a tangent to this graph, and let's find a secant also. Get that secant, and I would like to change the color of the tangent. We got a secant to this the other curve also, tangent and secant. Okay, I wanna do something. Let's make the other thing also feasible. Okay, here look at observe closely. The blue lines are the secants and the yellow lines are tangents. Look to the two different curves. Okay, looks beautiful, but I wanna make it. There are two different points where we can adjust this tangent and I only want one point. So instead of taking L as the other point, I'm taking it P. So let's equate it to L is equals to P. Let's say, look here. See, by moving only one point, I can get these both points. See how beautiful this is. By just moving one point, I get these two lines. Okay, this looks so beautiful, right? We can change it and play with these graphs. But let's jump into a question to check our understanding of it. Okay, look at the question. Find the angle between the curves x into y is equals to 2 and x square plus 4y is equals to 0. So we have to find the angle between these two curves. First, let's make these two curves. Okay, first one x plus first curve will be x plus, so we are taking y is take y as f of x, therefore y is equals to 2 by x, right, comma, and for this equation for y is equals to x square by 4, right, y is equals to x square by 4. See, let's see. So I'm taking it y is equals to, taking one equation y is equals to x square by 4. 4. This is the red line equation y is equals to x square by 4, and the other equation y is x 2 by x, right? 2 by x. See? Okay. Let's first just look at the graphs. I'm eliminating all the other secants and tangents. Okay, look here. This is the graph. These two graphs look somewhat alike. Like we have to find, listen, check the question. Find the angle between the curves. We have to find the angle between these two curves. So we cannot find the angle between two curves. We have to find the two curves. We first have to find the intersection point. See what is the intersection point? 2 comma 1. You can get this answer by equating 2 by x is equals to x square by 4. So you can get it, the answer. 2 comma 1. At 2 comma 1, these two curves intersect. So we have to find the angle between these two at 2 comma 1. So how do we able to find there is no formula for finding the angle between two curves. But if you zoom in closely, these two curves appear to be a straight lines. We just have to find the angle between these two straight lines. How do we? But there is no equation for this slopes for this line straight lines. So let's draw tangents. Okay, let's get our tangent equation ready. See, I got a tangent here and another tangent yellow line. See, okay, but let's move the point P's. What the? Okay, here is our point P, right? Look at here. Hey, if you observe closely, look at this. As I move this point, one becomes as a tangent to the green line, and the other is a tangent to the red line. Okay, we have to find the angle between these two lines at this particular point. What point? 2 comma 1. Okay, let's see. Is it 2? Okay, where is the point these two lines intersect? 2, right? The p value has to be 2. Let's adjust the p value to be 2. Small, okay, small, that's 2. Okay, here, look at here. We just have to find the angle between these two tangents. If you are a bit doubtful, you can check it. Let's zoom. Here, see, these two almost look identical, right? So we just have to find the angle between these two lines. We already know the slopes of these two lines, right? One is g of p and the other is k of l. So what is the formula? Tan theta. So therefore T is equals to tan inverse m1 plus m2. What is the m1? G of x minus k, k of x. Sorry, we just have to find it. Point P, right? So point P or L. So I'm taking L as the point. L and P both are equal, so it doesn't matter which we take. See, L is equals to P. We made a condition for this. So I'm taking, in a normal situation, we would take like the whole theta is 1 point. Hey, there should be a mistake because the angle cannot be. Okay. We here the system is calculating the angle in terms of radian. Let's change it to degrees. Okay, here we'll give at 2 point at p is equals to 2. The angle between these two are 71. Or also we can say that, let's see, tan of t and t is equals to 3. Tan inverse 3 or the value of this tan inverse 3 or 71 degrees. The angle between these two tangents. Wanna play a little bit. So let's change the graphs a little. Oh no, multiplied by 4, no. Fine. Okay, see, this this thing look beautiful, doesn't it? Now the graph intersects at 2 points. At one point, let's see what is the point of intersection. These two. Let's notch it. Zoom. It minus 0.83. Let's go there. What is the angle here? Tan inverse minus 2.067 or 64 degrees. Let's go to the other intersection point. What is the point here? It was 9.47, right? Let's go there. 9.47. Same. Hey, looks like the angle between these two are almost identical, not the identical, 67 degrees. Okay, let's check for another question. Okay, now let me wrap this. Okay, see, the other question is y square is equals to 4x, which means we can write it as y is equals to root of 4x, and the other thing is y is equals to root 32 minus 4x square. 2 minus 4x square, right? Square. Okay, let's see what is going to be the angle between these two things. See, what is the first one? Root 4x, and the second equation h of x be root 32 minus 4x square. Root 32 minus 4x square. See, as you can see, let's make these tangents invincible. Okay, look, these two are the curves and this is the point. Okay, this looks like an half semicircle and these two intersect at this particular point, right? At this point, so we have to find the angle. Find the angle. Let's make the tangents visible. Look here. Okay, how it is moving. See, at this point, where is the point of intersection? Find the point of intersection first. It's 2.372. 2.372. P is equals to, let's P, 2.372. See, angle 74 degree is a matter. There should be a mod in here, which I forgot to add. So it's a 74 degrees Celsius. You get it right? Or tan inverse, we can also say tan inverse 3.69. Like, okay, good. Let's, I'm undoing these changes. I want to look at the previous graphs which we modified and played together. Okay, look at this graph, the previous graph. See, let's make the secants visible. Okay, now see, now the secants are visible and you can observe something in details, right? Now the angle between these two tangents is equal to the angle between the secants. See how they are moving, and can we prove it? Let's see how do we prove it. I'm trying to do it. O is equal to, let's assume O be the angle between the tangents. So tan inverse and power minus 1. See what is the slope of this secant? Minus 1 by, so bracket open, minus 1 divided by g of L minus, now it's plus, minus of minus plus will be 1 over k of L or pk of p, both are same. L value and p value are same because of this condition here, L is equals to p. So I'm taking it as p to p. Let's have a mod here by 1 plus p. Now look at here. The angle between these two, the tangents and the secants is the same. Look here. If you want, you can take a pen and paper and try applying this, check the values. The tan inverse of, like, you can just equate it. G of L minus K of P over 1 plus G of L, G of L, K of L is equals to 1 over G of P minus 1. You don't have to substitute the values, we can just equate it, which means that the equation, like the angle between the tangents and the angle between the secants is the same. Look here, and these two things get changed forever. And let's make it a bit more funny. Sin x is x. Look at here. F of x is equals to sin x. Oh no, sorry. Let's change the angle between radians. Let's change it into radians to be clear. See, look at here. And the other wave to be, let's say, cos x. Cos x. Wow. Look at here. See, the angle between, same, even if you take cos x and sin x, the angle between these two lines is the angle between the secants and the angle between the tangents is the same. How the secants and tangents are like rolling over these curves. See, okay, have you ever wondered like let's make it visible. What is the differentiation of sin x? It's cos x. If you make the blue line which is differentiated, it just overlaps. Just increase the contrast to look at that. See, this is the green color is the cos x graph, right? When the g of x, differentiation of sin x is cos x, these two lines will overlap. If you observe closely, wait, let me change the color to black to be able to see it more clearly. See, look at this g of x. It just overlaps with the green graph because it's also a cos x. So it's gonna look like that. But when we get the k of x, it is minus sin x. Look, how does this minus sin x looks like an anti, like opposite to the sin x graph. Look how the red graph and the blue graph looks. These two things are looks totally opposite to each other, right? Hey, have an idea. Why not take this differentiated? Instead of cos x, why not take minus sin x? Minus sin x. Look at here. Sin x and minus sin x. These two are the graphs. Look here. Reduce the contrast. Look. Sin x and minus sin x both are the graphs, and the